Hi everyone. Let's take a brief moment and look at this situation where we'll compare NPV to internal rate of return, and then we'll also take a look at the modified internal rate of return. Okay, we're going to assume a very simple example. We've got a project, or we have a couple alternatives, and alternative P will require 200 out-of-pocket cash, and let's just assume that's in thousands. So 200,000 out of pocket, and then the cash flows that they're going to expect in terms of positive return will be 140,000 at the end of year 1 and 128 at the end of year 2. So I'm reading these numbers right here. And we'll assume the proper discount rate or cost of capital, which represents the opportunity costs of everything else the firm could do with its capital other than taking this project on. And we'll also assume that discount rate is adjusted for the risk associated with this project, is 10%. Then we'll compare it to Project Q, which is a smaller project, one where we see the numbers here. The initial investment is 100,000 that we have to fund. You could assume this is for, say, a piece of equipment as well as working capital. And then we expect some positive returns from this alternative in the tune of 80,000 at the end of year 1 and 56,256.25 at the end of year 2. And again, we'll assume that this project is of comparable risk to Project P that we discussed just a moment ago. Okay, well, let's go ahead and calculate the NPV for it. So I'll type in NPV, hit the left paren, and then I'm going to hit the formula bar, which you can't see above your screen, but it's a little F sub X, and it will call up a screen. I'll put a little bit of it on the screen so you can see. It says, where's the rate? We'll go get the rate from there. We'll lock it in, and then under values, we will highlight the values at the end of year 1 and 2. Now the reason why I'm not highlighting the end of year 1 is because we assume the cash flow occurs immediately. In the NPV formula, let me hit enter. Okay, that formula so far is just the present value or the net present value right now. That's at period 0 in our model of those two cash flows. So then what we've got to do is then add in the initial cash outlay. So we add that in, and we come up with an NPV of $33,000.26 or $33,260, right? We're going to assume the dollars are all in thousands. Okay, now the reason why I put the discount rate in both columns is that way we can just copy this formula and come up with the NPV for Q, for Project Q. Okay, and sure enough, all the numbers all line up. All right, now let's do the IRR, which the internal rate of return. We'll just do an equals IRR left paren, and this time when I hit the formula, the formula bar, we can just select all the values. Just put it right down there. It wants a guess. I usually use the cost of capital as the guess, and I'm calling the cost of capital the proper discount rate in this presentation. Okay, hit OK, and I've got 22 by. I've got an error here. I've got a negative in that first position. Let me delete that here. I'll hit the F2 and delete this. Okay, so 22.4%. Okay, I'll hit the F2 again so you can see. All we're doing is we take the internal rate of return by highlighting the range of cash flows and then giving it the guess, which I use as the cost of capital. And then I will copy that here as well. Okay, for sake of, well, at this point, let's talk about what we know. The best alternative using NPV, you could look at this and it's the higher alternative, right? But I'm going to get fancy and use an Excel max function. So we'll hit the max, open the formula bar, and then tell it the two numbers, which are these two, right? And I'll hit enter. I know you can't see all of that on the screen. I'd have to slide for you to see it, but here you can see a little bit of it. Equal max left paren, and it's just cells D11, D12, close paren. Okay, and what it's telling you is the higher of the two values, the 33.26. So that's the best alternative. Project P makes more sense. But in terms of internal rate of return, I will paste that one down there and change that to the right format with 1 decimal point. We see that Project Q is the better alternative. Okay, so what does this point out? It points out the weakness of internal rate of return and how it could mislead you. It is true that Project Q in this simple example leads to a higher valuation in terms of internal rate of return. But are the stockholders or the shareholders better off by choosing Project Q over Project P? And the answer is no, they're not. They'd be better off with the lower return because in terms of the net increase in wealth, which is determined in dollar value, 33.26 is certainly higher than 19.21. So this points out that NPV is the superior metric to use in judging between alternatives. Okay, and it's a superior metric to use in capital budgeting in general. Let's also take a look at the modified internal rate of return. And with the modified internal rate of return, the difference is we don't assume that cash flow that is generated throughout the process is invested at the internal rate of return. We assume any positive cash flow is invested at the cost of capital, and any financing needed is also invested at the cost of capital. So here we'll choose the values, and again we'll just highlight the whole range. Only now we say the finance rate will make it equal to the proper discount rate of the cost of capital, and the reinvestment rate of any cash flow that is positive throughout the length of the process is that same 10%. I'll slide that over so you can see the numbers here. Okay, and once we have that, I can hit OK, and we get 19%. I can copy that over. Okay, and what does this reveal? By the way, I want to bold this one, saying that this one is the one we're going to choose in terms of the maximum value. This one should not be bolded at all, and this one would be bolded as well. Okay, well, what does this tell us? Well, it still tells us that the modified internal rate of return gives us an incorrect response. We're better off with NPV. Having an extra 33.26 thousand in our pocket is better than having 19.21. But what we do see is we get a more realistic view of what the rate of return will be if we were to choose Project P and Q. Okay, and you see that that internal rate of return of 25% begins to drop, and it drops because any positive cash flow that gets any positive cash flow that gets generated during the project is going to be invested at a 10% rate, not the 25% internal rate of return rate. And so the results we see are exactly what we would expect, a lower number, given that both internal rate of return was much higher than the discount rate. So with a modified internal rate of return, we'll see that the internal rate of return will drop and will fall somewhere in between the internal rate of return and the discount rate. Okay, but the main point of this exercise is to illustrate that net present value is the most correct metric to use in evaluating capital budgeting situations, or evaluating quantitatively the best alternative among choices. Okay, thanks everyone.